Now, given that character arrays and strings are sort of a special case of what we would like to see in when we are dealing with strings in C, there are a number of special functions that are written to deal with those kind of character arrays, right. One of the most common things that you might want to do is actually to find out the length of a string, right. And the problem over here is there is a function called strlen which is commonly used in order to find the length of a string. But as I said, it is quite possible that it does not actually give you the correct length of the string, because it relies on the fact that a string ends with the 0 character or the null character. What if purely by accident you have something which is not null, right? Then what ends up happening is you can potentially end up with the string len giving you a number that is not correct and is not even realistic, and could potentially even lead to all kinds of bad behavior of giving you data that is not supposed to be accessible and so on. There is a safer version of the function strlen which is called strnlen, which along with the string for which you want to compute the length, right, which is basically a character pointer or a character array, also takes a possible maximum value for that length, and it will not give you a value which is more than that maximum. This is one way of sort of making sure that you don't sort of go completely out of bounds and access data that you are not supposed to. Now similarly, if you want to sort of do things like initializing a string, right, if you want to do this with an integer array, for example, you could do the initialization at the point of array declaration, or you could have a for loop that explicitly puts values into the integer array. In the case of strings, there are a couple of special functions which can copy from one string into another, or take two strings and join them together, right. They are called strcpy for string copy and strcat which is string concatenate. So concatenate means to take two strings and sort of join them together, right. And as I said, there are like safer versions of these that do not have the problems related to the null bytes missing at the end of the string and so on, but basically we will look at a couple of examples of the string copy, string cat and so on. Similarly, another common operation that we have with strings which may not be so common with integer arrays, for example, is to check if two strings are equal, right. So it is unlikely that I would take two integer arrays and very often want to check whether two integer arrays are equal to each other. I would definitely want to do that with strings, and strcmp, string compare, is a way of doing precisely that, right. And most of these functions have the default which is potentially unsafe because it has this 0 byte ending problem, and they also have safer versions that avoid that kind of issue, right. Mostly what we will be looking at is the basic version and also giving you information about where to look up and find out a little bit more about the unsafe versions, or rather the safer versions. Now lastly, before we look at some more of the examples, it is also possible for strings to be something more than just ASCII, because the world is not just restricted to the English alphabet, right. In fact, in India we have several languages, right, that are in much more than what can be represented using 8-bit ASCII, and Unicode is an encoding, a character encoding that is currently used in order to represent various kinds of different scripts and different kinds of characters, right. It is a multi-byte encoding for the simple reason that 8 bits, 1 byte has a very limited range of characters that can be represented. It will definitely not be enough even for the Indian alphabets, at least not all Indian alphabets, right. Maybe one or two of them might be able to fit within the 256 bytes that you have available for ASCII, but ASCII has already reserved most of those in terms of various symbols. So rather than trying to change those around, the decision was taken, let us expand it to this form called Unicode, which is a character encoding. The exact nature of Unicode and the full breadth of what is covered over there is not something that can be covered in this lecture, but there are some parts of it that we have already touched upon and we will be looking at in various different contexts, right. What we need to know right now is the fact that it can be used in order to handle the range of characters beyond what can be done with ASCII. it can handle multi-byte encoding, which means that characters that could not be represented with ASCII would be represented using multiple bytes, not just a single byte. What that means is a Strlen function, which just counts the number of bytes, may not be accurate anymore. There are a certain set of representations called wide characters that are commonly used within the context of different operating systems and different compilers. And so WCSlen, for example, is one of those functions which can be used in order to find out the string length of a wide character string. Okay. Now, how exactly do we use these? What are the different ways in which to use this? We will be looking only at the very basic forms of how we can use wide character strings and so on in C, right. The full details of how to handle these is itself a fairly complicated problem. So, we will be looking primarily at the basic usage scenarios. Part of the reason for this is that some of it is also dependent on the operating system and the libraries that you use in order to handle Unicode, and in a lot of cases it is not part of the C language specification. Okay. So, with that in mind, let us look at some of the functions that are available to deal with strings in the C language. So, this function that we are looking at over here is going to essentially illustrate the strlen or the string length function. Okay. So, what I have over here is I have declared a char s, a char array, and I have said that it has a maximum size of 50 bytes. Okay. So, in other words, it's been declared as an array of size 50 bytes. What that means is that the compiler and the runtime, which actually executes the program, are going to set apart 50 bytes in memory for the usage of the string, right. But I have also initialized it to this particular value hello world, and clearly this is not 50 bytes, it is significantly less than 50. Okay. So, let us see what happens if I print this out over here, right. Basically what I am going to do is I am going to first ask it to print out s, then print the size of s, and then finally print out the string length of s. Okay. And let me just comment this part out for the time being, we will get to that in a moment, right. What happens when I run this is that I can see that the string itself got printed out nicely, hello world. You will notice that I do not have the \n over here. If I did, then this would have gone to the next line. So, I did not want that to happen, so I left that out. In the printf itself, at the end of it, I have given a \n. Now, that is useful to have, so that at the end, after all this, it goes down to the next line and brings me back to a prompt where I can type something properly, right. Otherwise, this prompt character would probably have ended up at the end of the previous line, which I do not want. Okay. So, it printed the string itself, which is hello world. The size over here is the size of s, and it says that is 50 characters. Why? Because I declared s as type char s of 50. So, as far as the compiler is concerned, s is capable of holding 50 bytes, that is its size. Okay. And the next thing is, what is the actual length of the string though? The string length is given by actually measuring it. I have 5 characters in hello, one for the space and another 5 characters out here, right. So, that is 11 characters, but it actually uses 12 characters internally. Why? Because there is one more byte after this in order to store the null character that terminates this string. Strlen does not count that null byte. Okay. So, it starts from h, goes up to this element out here, that is the d. It does not know to stop at the d, it actually stops when it sees the 0, and once it sees the 0 over there, it will say okay, now that is the end of the string, but I am not going to count the 0 as part of the string length. So, what you have is a length of 11 actual bytes that are used. So, hello world corresponds to 11 bytes. In terms of storage, it actually takes 12 bytes because it needs the null character at the end. Okay. Now, what I am doing over here is actually sort of playing around with the compiler, right. I am explicitly trying to take s of 5. What does s of 5 correspond to? S of 0 is the capital H, s of 1, s of 2, s of 3, s of 4, s of 5 is this space character. I am making it 0. by just assigning 0 to it, right, it does not become the number 0, it becomes the null character, because the number 0, the ASCII code corresponding to 0, the character 0, right. In other words, if I had this out here, right, that would be the character 0, which has an ASCII code of 30 hex or 48 decimal, right, but that is not what I am talking about. I am talking about the actual number 0, right. And when I have this, let us see what happens when I run this part, right. So the first printf should actually print out exactly what I have out here, the size 50, length 11 should remain the same. But now that I have printed, put in this s of 5 as 0 over here, I want to know actually what happens to s, okay. Let us comment out this last line and see what happens first. Now you can see that the string got printed as just hello, right. What happened? The compiler, or rather the runtime, went through the string, s of 5 is now explicitly 0. So when it is trying to print the string out here corresponding to this %s, it starts from capital H, goes through HELLO, sees a 0 and says, oh okay, that is the end of the string, print it out and that is it, and incidentally the length of the string is returned as 5 bytes. Okay. So in other words, just by inserting a null character somewhere in the middle of a string, I can change the length of the string. Okay. What is even more interesting is, I could, since after all a string is just an array of characters, I just take the address of s of 6 and tell the compiler, treat this as a string and print it out for me. Okay. So what do you think is likely to happen? Well, let us see, s of 0 was this h, s of 5 was this space, s of 6 is actually corresponding to this w out here, and since I initialize the string properly, I should find that WORLD is followed by a null character, which means that it is a valid string. Okay. And I could potentially do something like that. Let me even print out the length over here, right. strlen of ampersand s of 6, right. And what you can see is it printed out the string hello, the remaining part it printed out world, and it told me that the length was 5. This is not the string length of s. What it has done is it has taken ampersand s of 6 as a new pointer to character or a character array, started exactly at this point corresponding to w, which is what it has printed out here, and started counting until it encountered a null byte. And at that point it basically said, oh okay, so the string length of whatever started at s of 6 is 5 bytes. It does not have a name corresponding to a character array, but I know that it is a pointer to a character, so I can treat it like a string, compute its length, and this is the result that you get. Okay. So keep in mind that character pointers, character arrays, they are very similar. There are occasionally places where they do behave differently, but for the most part all that I really care about is I have a pointer to a location in memory. If it is a string, I just look at characters until I hit an invalid, not an invalid, a null character to indicate the end of the string. Now this is a set of functions demonstrating various kinds of the string functions that can be used in order to manipulate or copy strings or change the values of strings and so on, right. An example of this is I have declared two character arrays, s1 100 bytes, s2 100 bytes, but I have not initialized them, so they do not have a value to start with, right. So the question is, can I just do something like, for example, s1 is equal to hello, right, and you will realize that this is not going anywhere. It basically straight away gives you an error, right, as you can see by the red bar out there, or if you try compiling it, it would give you an error. And the error is also, it's a nice error message that it's actually giving you over here, which is that the array type char of 100 is not assignable, right. I cannot assign to an array type. I cannot take a sequence of characters and directly try assigning them into an array. It doesn't know what to do, right. I need an explicit function, right. So I'm going to get rid of this line out here and look at the next line which does exactly what I want. This is a function called Strcpy, which takes an array of characters or a string of bytes and copies them into the correct location. So this is literally, that's what it's doing. It's going to take those bytes and copy them physically into the memory locations corresponding to S1 of 0, S1 of 1, S1 of 2 and so on. And then of course I can print it out, right. This string implicitly has a null ending, which means that all the characters including the null and so on will get copied over, and when I try printing it out I see hello there, perfect, exactly what I would have liked to see. Okay. Now what I am going to do over here is I am just going to check whether S1 and S2 are equal, right, and in this case basically it means that the two values did not compare to be equal, right. But what I can do is use another function called Strcpy, or rather the same function Strcpy that I used in the first place, to copy S1 now into the string S2, right. So previously what I did was I gave a constant string and asked it to copy it into S1, right. Now I take the S1 string and copy that into S2, right, and what I get as a result is when I try comparing the two, I find that the equality check actually passes. It gives me that yes, they have compared, or rather that they are equal, right, and I can try printing out both of those strings. S1 and S2 can be printed out, and what happens when I run this, I basically find that S1 is also hello there, S2 is also hello there, right. And if I went and did something else after copying S1 into S2, right, I basically say S2 of 0 is equal to, let's change the character to something else, Y, okay, and then see what happens out here. Once again I find that the equality check failed, it did not return a 0. That's the only thing that Strcmp actually guarantees, right, that it's not going to give you a 0 unless the strings are actually equal. And sure enough I can see that S1 is hello there, S2 is yellow there, and there is clearly a difference in the first byte. So it compares the entire string, okay. There is also a function called Strcat, right, which can be used to add something to a given string, right. In this case what can be done is that I can do a Strcat onto S2, right. When I do this, this is something new and I print out the value S2 is equal to this. Let us see what happens. Immediately after that what I am doing is I am doing a Strcpy, right, with exactly the same string. This is something new, okay. So the question is, what's the difference between these two, right? One of them is using Strcat, the other is using Strcpy, right, and what is happening in this case, if you think about it, is S2 already has something in it. The Strcat is going to add to it, whereas Strcpy will just overwrite whatever was already there in S2 to start with. So let us see how that works. So you can see that S2 had the value yellow there out here, and this is something new gets immediately appended after that, right, not even a space, not a single character, nothing else after the yellow there. Immediately after that it starts off with this is something new. So Strcat literally looks up to the end of the first string, that is S2, and from the very next byte, which is actually the null byte, it starts putting in the characters corresponding to whatever needs to be added on. Strcpy on the other hand did something completely different, related but different, in the sense that what it did was it completely ignored the fact that S2 already had something in it, right. It went back to the beginning of S2 and started copying the string over there, right, and it ends up with this is something new being copied right into the beginning of S2, right. So it is also of course possible to look at this length of S2 after each of these operations, right. We can quickly check strlen of S2, and we can print it after each of these, right, and see what happens. And you will see that after the string cat, it basically went up to a length of 34, but after the string copy, that it got replaced by only whatever was in here, which is of length 23, right. So it's quite possible to sort of play around with the structure of different strings in this way, right, and to sort of see what happens as a result of changing the different characters around. So finally, a demo of how we can use different scripts, different fonts or characters as part of the C language, right. And you can see, for example, that I have got a char string declared over here, which has the characters Namaste India written in, where the Namaste is actually in the Devanagari script, right, and the India part of it is in ASCII, right. And this is kind of interesting. I mean, this is literally sort of, you can type out these characters one by one using the appropriate kind of input format, right, or you could go to something like Google Translate, type it in one language, translate into another and copy paste, right, in order to get a particular string across, right. So if you have a keyboard which can switch over to the Hindi or Malayalam or Tamil or any other local script, you can of course use that. If not, you could use something like Google Translate to get this if you want to play around with it, right. So what has been done over here, of course, is I have declared it as a string, right, and you can see that as far as the editor is concerned, right, Replit itself does not care, it is able to perfectly display these strings, right, because it knows that these are the characters. What happens with the printf function? Let us see what it does with it. Yes, it is able to print it out as well. You might notice that what gets displayed over here in Replit, right, in the editor versus what got displayed out here, right, on the console, they look slightly different. And the reason for that is different fonts have been used for the two cases, right, or rather the string handling is being done in a slightly different way between the two cases, right, and the way that C actually takes care of this half sa and prints it out is different from the way that the editor is actually using in order to display it, okay. Now this actually gets quite complicated the further that you go into this, but there are a couple of interesting observations that we can make over here with regard to what the encodings are that are used, right. The complete use of Unicode is not something that we are going to focus on as far as this course is concerned. It is much more complicated than what can be done over here, but it is useful to at least know that all of these ultimately are bytes sitting in the memory of the computer and how we can sort of handle them, right. So as I said, you can also do a couple of other things, which is there is something called a Wchar, a wide character, right, and if I declare a wide character string S as this particular string out here, right, Namaste India, notice the L over here to indicate that it is a long string. In other words, each of the characters over there should be represented as a wide character. What is a wide character? It basically says that every character that you have over there is going to be represented by multiple bytes. Every character, including the so-called ASCII characters that need only one byte, will get represented as multiple bytes. How do we visualize that? So a wide char is something where each character is multiple bytes, but we know that a char star is just 1 byte each, right. It is a pointer to something where each element in that array or each element referred to by that pointer is 1 byte. So we have this char star SS, which is a pointer to character. I have taken S, which is a pointer to Wchar, a wide character, typecast it as a char star, which means that I can now basically access individual elements of the wide string, okay. But before we start accessing the individual elements, let us look at some of these functions, the string length and so on, and what they return, right. In fact, it is not even clear exactly what it means to say that, you know, we have a string like this. What is the length of the string, right? How many characters should this get counted as? That partly depends on, there are a lot of interpretation mechanisms at play over here. So in some cases it may not always be obvious exactly how the length should be defined. There are standard procedures that are defined for how this should be handled, and the library functions basically implement those. So one of the things that you will notice is that the string length came out to be this number 2, right, which is actually a very strange thing, which we will understand why in a moment once I actually start printing out the characters, right. But if you think about it, it really looks strange. Why would the string length of something like this, which clearly has so many characters, why would it look like 2? And the simple reason is, if you think about it, it's related to how string length works. All that it does is go through and search for a 0 byte. And as we will see, wchars, wide chars have a lot of 0 bytes in them. Okay. So the string length clearly is something that doesn't work for our purposes. Let's leave that out of the picture, right. Let's not even think about it further at this point. What we'll do instead is, the WCS_len on the other hand is probably what we need, right, because we have declared S to be of type wide char, and when we look at it, it seems to say that namaste is somehow something like 6 or 7 characters, which is why you then add the space and India and you end up with 12 characters. So maybe the namaste somehow came out to be 6 characters. Why exactly? Well, maybe depending on how you count half characters and so on, okay. But the size of the string itself, right, which essentially just got counted from this, remember how size of works, it would actually count the total number of characters that are present in the string, include the null that is required in order to terminate the string, and then give you that many bytes. In this case, you look at the WCS_len, and that is telling you that there were 12 characters. Wide characters take 4 bytes each in internal representation, okay, and there is a 4 byte wide null character at the end, right, which basically adds up to a total of 52 bytes, which we see as the size of S. That is literally the size in bytes that is occupied in memory by S, okay. And to understand that clearly, we can actually go ahead and print this out, okay. Now this should actually tell us exactly character by character, right, at each memory location it is going to tell us what SS corresponds to. What is SS? It is literally telling you what are the byte values, not the wide character values. So let us go ahead and look at that, right. When we run this, we find that a whole lot of data gets printed out, so we need to sort of go back and look at it carefully, right. The character at 0 is something, it says it is a open parenthesis, but more importantly it is 28 hexadecimal, that is what matters, okay. The character at byte offset 1 corresponds to, it is showing something which looks like a space, but is actually 09 in hexadecimal, and then character at 2 and 3 are 00 and 00. Now this first of all explains why string length thought that the length of this particular string was 2 bytes. It started over here at character 0, saw something non-zero, so far so good. Character 1 is also non-zero. Character 2 is 0. It stops right there and says the length of the string is 2 bytes, right. Clearly a wrong answer, but the string length, that is how it came out to this number 12, or rather 2, okay. What about the wide characters? Let us look at it more closely. What it is doing is that it is basically printing out individual characters, and given that we know that this is the Little Indian format and so on, basically this corresponds to a character 00000928, okay. It is essentially a Unicode representation. This is the code corresponding to a particular character. What character is it? We will look at that in a moment, okay. And then you have 00000928, that is another character. 00000938 is another character, 094D is another character, 0924 is another character, 0947 is another character. You will notice that what gets printed over here is mostly garbage. I mean, that there is no connection between this and any of the Devanagari characters, right. But what is interesting is after 1, 2, 3, 4 and 5 of these, or 6 of these characters, all of which, if you will notice, have this format 000009 and then something, right. Then we finally come to 20, which hopefully you remember from one of the earlier demonstrations is the space character, okay. After that I come to 49, which is the character I in ASCII, but it is now expanded out into a 4 byte value where the top 3 bytes, the most significant bytes, are all 0, right. N is 6E in hexadecimal ASCII, right, small n, and the other 3 bytes are 0. So effectively what has happened is the ASCII codes for INDIA have all been taken, padded out into 4 byte values, because that is the Unicode corresponding to those values, right, and the whole thing gets printed out until finally over here I end up with 4 bytes, which basically, or rather these last 4 bytes actually indicates the end of the string. Okay, that is how WCS-len worked. It actually sort of took the long characters, the wide characters, counted them as being these 12 bytes, as 12 characters, and printed them out. Just for clarity, we can also try this out where we actually print out, the first character and so on, right. And what you will see is that it actually is able to show that the 00000928 corresponded to the character N. Okay. The next one, the 2E, if I change this to 2E, I will find that it corresponds to the M. Okay. So in this way, this notation out here where I have used this \u, one more of the escape codes, right, is actually used in order to represent the complete notation of all Unicode characters. This is 4 bytes that needs to be specified in hexadecimal. It will actually go interpret it as Unicode, find out the corresponding character and print it out for you. Okay. So Unicode is one of those things that can be used for handling multi-byte strings, other kinds of languages and so on. It is potentially also, it is very useful for internationalization. It is a bit more complicated and we will not be going further deeper into it as far as this particular course is concerned.